Hey everyone, welcome to Bonbon Science. Today we will be going over Unit 1, Topic 1 in AP Chemistry called Moles and Molar Mass. So let's just get straight into it as we start our chemistry journey. So the first question you should have for me is, what is a mole? And to understand what a mole is, or more specifically why we use moles, we have to understand what we're doing in chemistry. Chemistry is fundamentally the study of matter, and that includes elements and compounds. But it is very difficult, if not impossible, to study an individual element or compound. And in fact, let's take a look at your typical atom to demonstrate why this is. So I'm going to draw this quick little atom here. We'll say that's the proton, that's the neutron, that's the electron. Not a perfect drawing, but you get the gist of it. This is a typical hydrogen atom, right? But even though it looks very big in my drawing, atoms are microscopic. And so even if scientists were able to zoom in with the microscope and see the individual atoms in a substance, right, there's going to be so many of them that it's going to be very hard to count. That's the problem. It's very hard for scientists to count all these atoms individually because there's so many of them. And scientists want to be able to count them because when they're doing their experiments, they want to know how many atoms and particles are reacting, so they need to know how many atoms are involved. But if they can't count them, then what are they going to do? Well, that's where the mole comes in. For AP Chemistry, we can just define the mole as a unit of amount of substance. So I will write that right here. Unit of amount of substance. And so that's very vague, but don't worry, I'll clarify in a second. Because the main problem is, what is the amount in a mole, right? If a mole is a unit of an amount, then what is that amount? Well, that is what we call Avogadro's number. That amount is known as Avogadro's number. So let's write that down. Avogadro's number. And Avogadro's number is equal to 6.022 times 10 to the 23rd. And that's massive, but keep in mind that atoms are very tiny, so it works out for atoms because we're typically dealing with a very, very large amount of atoms in a lab setting, right? And so if you have a mole of something, you have 6.022 times 10 to the 23 of it. So if you had a mole of dogs, you'd have 6.022 times 10 to the 23 dogs. If you had a mole of atoms, you have 6.022 times 10 to the 23 atoms. But that still doesn't answer how the mole helps us figure out how much of something we might have. And so to understand how that happens, we need to use something called the molar mass. So you can see here, this is carbon from the periodic table. You can see the atomic symbol C, you can see the name carbon, and right beneath that you see this number 12.011. This is the atomic mass, which is the mass of a single carbon atom, and that's an AMU, which is just the units we use when talking about a single atom. But coincidentally, this is exactly equal to the molar mass. So remember that atomic mass is equal to molar mass. So when you're looking on the periodic table and you see the atomic mass number, it's the same as the molar mass number. And so I know I keep saying molar mass, you might not know what molar mass is. Well, molar mass is the mass of a mole, as the name would imply. So it's actually pretty simple to remember. So I will write that, and I apologize for the bad handwriting, but it's mass of, we'll say mass of mole. And it's measured in grams. So essentially, for carbon, we know that the molar mass is 12.011 grams per mole. Every mole of carbon will weigh exactly 12.011 grams. And this is very cool because it gives rise to this equation. N equals little m over big M. N in chemistry usually means moles. Little m in this equation means mass. Big M is molar mass. And so let me show you how we can use this equation, because this is what's going to make the whole lesson click. Let's say we have 6 grams of carbon. We want to figure out how many moles of carbon we have. Well, we have this equation, right? It gives us moles. We just need little m and big M. Well, little m is just going to be our 6 grams of carbon. Big M is our molar mass. We look up here. That's just 12.011. So we can just divide the two. 6 grams of carbon divided by 12.01 grams per mole of carbon. And plug that into a calculator if you want, but that will give you 0.5 moles of carbon. So we figured out our moles of carbon. let's say we want to take it one step further and figure out how many atoms of carbon we have, because that's what we were trying to do initially, right? Well, we have 0.5 moles of carbon, and how many things are in a mole? Well, for every 1 mole, we have 6.022 times 10 to the 23. And here we're talking about atoms of carbon, right? Because that's what we're trying to find. So if you were to do the math here, well, you would get that we have 3.011 times 10 to the 23 atoms of carbon. And plug that into a calculator if you want. But notice what we just did. We just figured out the atoms of carbon we have from the mass. We didn't have to sit down and count it, but we still figured it out by using n equals little m over big M, by using molar mass, and by using that concept of the mole. And so that is why we use the mole. And that's the whole point of this lesson. So I hope you guys found that cool. Thank you for watching, and goodbye.